and what are trends that are seen in data warehousing. Well, uh, the subject that we are studying, data warehousing and data mining. The concept of data warehousing, I hope you have learned in the previous block or in the previous sessions that data warehousing is basically storing information at a particular place so that we can perform some mining on that data, right? So in the mining process, before we start with the mining process, and when we are putting data inside the warehouse, in our warehouse, the first step that we do is the ETL process, or we also do the ELT process. So there are two types of processes that can be done. First is you extract the data, you transform it, and then you load it into the warehouse, or you can first extract it, load it in the warehouse, and then transform it later on. Okay, so let's begin with the first fourth unit, which is what is ETL and why it's needed. Why do we need a ETL? And give me 1 second. Let me just close the door. Okay, yeah. I hope I'm audible. Okay. Um, yeah. So what is ETL? Why and why it is needed? See, we are in warehouse. We are collecting data from various sources. For example, the data can be coming from my payment systems, my booking systems. So, for example, if you take the example of a traveling company, so you have users booking their flights, you have users booking their train, you have users uh, making payments, and we have sales team. They are doing some pitching and all that, and that data needs to be stored somewhere, and that data is being stored. It is being stored in some database, right? Which is for your real-time transactions, right? OLAP. And then what we are going to do is we are going to study that data. To study that data, we need to bring the all of that into a separate place, into another space from where we can do some extra work on it. So you will have data that is coming from your uh, analytical systems. You have data coming from your payment systems, logistics, and all that. And then those data can contain some extraneous values that we need to remove before we can do some mining on it. And why are we doing mining on it? To understand our customers better, to understand how we can make our services, or what kind of services we can bring in, or what kind of services is giving us more result or making us profit, right? Or and to do some trend analysis as well. We saw that, right? Trend analysis is what, like during the festive seasons, it is seen that the number of flights booking has been increased, or the number of train booking is increasing, and there's a particular train that is being booked more frequently. Okay, there might be a trend that from metropolitan cities, people are booking more. So because during the festive seasons they are traveling back to their homes, right? Maybe in some other state. So that kind of thing, that is called data mining. Information, you are taking out information from the data that is present in front of you. And another thing that you need to know is there's two kind of terminologies that is used. First is data, and the second thing is information. Data is raw facts and figures. If I give you something like this, say, So, what this is just data. We are seeing something that is just there. There's some raw facts. These are just facts and figures, and there's no information behind it, right? Like, what is this number? What is this 1 2 3 4? What is F? What is come on? This is state that is okay that we can infer. What is NDLS? That's the New Delhi railway station. Could be ALB. I forgot the code for Allahabad, so I'm just using ALB. Okay. Now, our what do you say? Data mining process will determine. We'll look at all these datas. Okay, there will be multiple rows of these, and then we will try to make some sense of it. We will try to find some meaning behind that data, and that meaning that we are talking about is called the information. Okay, and before we can begin that information mining, and another thing is that data mining, and there's another thing called machine learning that you will be learning in the next semester. So it's very crucial that you understand what is data warehousing and data mining, because these concepts are going to be used in your succeeding semester as well. Okay, so why is it needed? Because your data will contain some garbage values, or your data will contain some values that doesn't make sense, or it will contain some data that is an outlier. What is an outlier? Outlier is something that is not uh, going with the mean of the data. For example, if you take the if you have a class of 100 people, and I'm trying to get the income. I'm trying to find out the mean of that income, mean of the income of that group, and it comes out to be, say, for 40,000. Okay, it comes out to be 40,000, and in that data I can see that some people have, most of the people have income ranging in the class interval of 20 to 40,000, and then 30 to 50,000, and 50 to 60,000. But there are two or three people whose income is like 1 lakh, 2 lakhs, and there are some people whose income is 5,000, and these points are called outliers. Okay, we need to get rid of these outliers as well, so that they don't skew our, or they don't mess with our analysis. So ETL process consists of three things. Extract, you extract information. Okay, you extract data from various sources. Then transform it. Transform, you are getting rid of all those nuisance, you're getting rid of those noisy data. And then finally loading is, you are loading it into the warehouse. The warehouse is another database, another big database, and this is usually known as a cold storage. Okay, we are putting it into a data lake basically, and inside that the read write is very you can say it's low, because there's obviously no structure. We are compromising on our data accessibility. So we might be using some kind of HDD instead of an SSD. So we are loading it into some space from which we can later on get the data and do some analysis. Okay, so let's look at the processes here. Here you see that we are extracting. So it could be some operational system. What is an operational system? You have some if payment is going on, that is a operational system. You have someone is making is booking something, booking a restaurant or booking a flight. That's your operational system. Then you have an ERP, enterprise resource planning. uh, Maybe the company that is making the flights and all that, they have their own internal software through which way they assess these flights and all that. Then you have CRM or some SQL database also. We are gathering information from various things. And then you have some flat files, spreadsheets, all those. And all of these are coming into this process. Okay, this process. This is the ETL process. So you have various sources, and all of these sources are going to be converted into a single entity. They are going to be converted into a entity that can be stored in a another database, which is known as data warehouse. Okay, and the ETL process is consisting of, you need data validation. Data validation is, you are checking whether the data that is coming in is valid or not. There's some error in the data or not. Okay, then you are cleaning the data. You are getting rid of missing values. You are getting rid of what do you say, uh, outliers, those things. Transform the data. You are doing performing some normalization so that all the data can be ranged into to a set 0 to 1 that we will study. Normalizing, you have min max normalization, you have z score normalization. Then you are aggregating the data. You are combining all the data, and then you are loading it into the warehouse. So the first process is data extraction. Identify the data to extract. Now there's you have information coming from various sources, and from that maybe there's some particular set of things that you want to be ingested. For example, if you are getting data from a flat file, you might not want to store the storage space of the file size. That might not be the relevant case in in our point, right? So we'll just ignore that one. Then we estimate how large the data extraction is. How large the data extraction is going to be. For example, in our storage uh, or our warehouse, it's only consisting of say 10 TB. So when we are extracting, we are going to keep the data such that it doesn't exceed some certain limit, because we don't, this extraction is going to be this ETL process will be going on every day, right? So every day if you are extracting 50 GBs of data, then my space will be filled rather quickly. So I have to take care of that as well. Okay, otherwise there's only one thing you can do, that is increase the hardware. Update your hardware so that it can handle that a large amount of data. So instead of 10 TB, maybe I'm installing 1 petabyte of or 10 petabyte of storage. Then we are choosing the extraction method. The first one is the update notification method. In this method, what you do is it will send in notifications when some record has changed. Because say someone made a booking. Okay, someone made a booking on 3rd of May, that is previous day. 3rd of May they made some booking, and then that data was extracted and put into our warehouse. Later on, what happened is on the 4th of May, that is today, they decided to maybe update something, or maybe they deleted it. Okay, they canceled their flight. Now that cancellation data, that is an update, right? Update call or delete call, whatever it is, that data is being sent to my warehouse. Okay, it's sent to my warehouse, and my warehouse is going to ingest that data. Another thing that you have to remember is, inside a data warehouse there are only what we the operations that are done are only read, write. We never delete data. Okay, we never delete data from our data warehouse. Not anyone has the access to delete it, except for the system admin and all that. But the principle is, once the data is inside the warehouse, it will never leave the warehouse. It should not be deleted. So your log will look something like this: that someone made a with this booking ID, someone named this made a booking of flight from NDLS to say some ALB or something. And then you have the timestamp, so which is 3rd May 2025, and this will be an epoch. It might be an epoch, or it might be a data string like this. timestamp like this, and if you are being true, it will look something like this. Time zone efficient. Let's say they made it at 11:45, 23 seconds. Point. Say this. This is basically a timestamp. Okay. Then what happens is on the next day, and this is, say there's another status booked. Okay. Then in our warehouse, the next data is that is going to be stored is that this person with this name that was traveling from this to this on this date, fourth, cancelled it. Cancelled it. Okay. The timestamp is supposed to become somewhere here, but all right, that's no problem. So this data was not updated in the warehouse. You can see that the book status was not updated to cancelled. Instead, what happened is another row was inserted in here. Why did we do that? Because we can do some trend analysis on this as well. Maybe not only this person canceled their flight, there might be multiple people who cancel their flights on that day, and then we can do some analysis to find out why they did that. Okay, so you can update your warehouse using an update notification. Whenever your database is getting updated, you send a notification to the warehouse, and the warehouse also ingest that data. Then you have incremental extraction. In incremental extraction, you are what you are doing is you are storing all that information. Suppose you have uh, made a system in which you only send 100 updates. Uh, Update your warehouse only when 100 updates has been performed on the actual data set, on your actual data source. Because if you look at this update notification system, this will create an massive overhead, right? There are millions of people. If my app is being used by millions of people, then the update notification system won't be able to work, because millions of people, if even only 500,000 people just update their booking status, my database will crash. First of all, my initial database will crash. Second of all, the data warehouse where we are storing the data is also going to crash, because it won't be able to handle 500,000 queries at once, right? No database can handle that. For that, we do sharding and all that,
Like in
which
one
you will.
day, like in one day or in once we are updating 100 notification we can send at a time.
Update notification is sent whenever you update something. Suppose I am updating my booking status right now, the notification will be sent that uh, immediately, because my
Okay.
database will be updated, right? My OLAP database will be updated, that is used for analytical. Sorry, my real time database will be updated, right? And then that database will trigger another syscall to update the data warehouse database.
So one thing that you said, like in data warehouse, we are store the data. We are
Yeah.
not deleting the data.
Yes.
So we have, suppose we have 10 years of database. So
Uh-huh.
that also we have store in our data warehouse.
Yes, we will never 10 years of data is like gold mine. You will never get you Why would you get rid of that information? Because on that 10 years of data, you can do some trend analysis, you can do time series analysis to find a trend, right?
So why it is required? My query is why it is required, because day by day people are
Uh-huh.
changing their names. Sorry, not name, numbers they are changing. Because using
Uh-huh.
mobile number, we are
Uh-huh.
sending update notification.
No, this update notification is not like your user is getting the yeah, of course. Suppose I canceled my booking status right now, and then I got a notification on my phone that my PNR with this thing has been cancelled, right? That's another type of update notification. That is also notification that you're sending. But in this scenario, what we're saying, that just like how you received an update, Data warehouse is also going to receive a notification, and that notification could be in the call in the form of a API call. It will send a API request that, oh, hey, this data has been updated, so you should also ingest this into your data warehouse inside your table, and then data warehouse will also ingest it into the table. Like previously, it was holding this information, and then after the notification, it is all is holding this information now. So,
Okay.
but in
First
the
we
real
book
time,
a ticket. Yes,
Mhm.
first we book a ticket. After that, when we cancel that one, the data warehouse store the cancelled like data also.
Yes, exactly. And in your real time database, from which you are where you from which you will be able to see your dashboard. See, you are not seeing your in your dashboard. The data that you're seeing is not coming from your data warehouse. It's coming from the real time database. There are two types of database, right? uh, like here, so from your operational system, this SQL database, you're seeing your data. Okay. And
Okay.
then whenever you update something, suppose you canceled it, so that request is sent to this SQL server, and then SQL server is going to update it, send you that information that, hey, your row has been updated, and then later on it will send another notification to the data warehouse that, hey, this data has been updated, so you should ingest this as well. And even if you delete something, that deleted notification, that deleted row information will also be sent, like this person has deleted this row. So in database, if you have worked with database, if you have looked at schemas of it, you will see that there are three timestamps that are being stored. The first is the created ad, the second is the updated ad, and the third is the deleted ad. These are three timestamps that are stored inside every table in a SQL database. So the created ad is when I booked, when I created my ticket from New Delhi to Kolkata. Okay. Next, when I changed the status was set to booked. Later on today, I cancelled it. Okay. Now the created at time is still 3rd May, but the updated at time is going to change to 4th May, and the booking status is going to be updated to cancelled, and then that information will be sent to the warehouse. So here, this is the created at, and say this is the created at timestamp. This is the updated at, because initially these two will be same, right? That you created it and updated it on the same day. So these timestamp will be the same, but the data that is sent, the data that is sent to the warehouse is going to be this. Later on, when you cancel it, you can see that the row is still this, right? This is still the created at timestamp is still same, but the updated at timestamp has changed. Previously, look at this one. When you booked it, though both the dates were the same, but when you updated it, it became this, and then it sent with the cancel notification. So you have the update notification function. And why will it fail? Because if 500,000 people just update their ticket, then my warehouse will fail, because it won't be able to handle that much traffic. Okay. Because I told you that we are using cold storage, and in cold storage the access time is already low, and the read write time is also going to be low. So when we do an update notification system, if we set up that thing, it will just just a disaster. The second one is incremental extraction. Incremental extraction is instead of updating your data warehouse every update notification, at every update call, what you can do is store those update calls in a queue. Make a queue of 100 updates, and then once it there are 100 queues, once the array is full, you send that notification to the warehouse. So the warehouse will ingest 100 records at once. that it can do. But if you give it one thing at a time, then it will be hard for it. Just think of it like it's moving. It has to move the data that you are giving it, and then it will take it to the next. It will take it to the its warehouse, to its location. So if you are providing it only one data at a time, then it has to do lot of work, right? It has to do some heavy back and forth. But if you give it a container full of data, then it just has to move that container into the warehouse. That's it. So that's just one unit of work. So incremental extraction is another strategy that we can use, and another is full extraction. Full extraction only works. The full extraction is you are taking the data fully. Yeah, that is at every midnight, say at 1 o'clock or maybe 12 o'clock, you are taking the backup of the whole data. So that's another extraction method. Now companies like Google, Meta, and these, they combine these two, incremental and full extraction, to uh, make it more reliable. Now, what is data transformation? Once your data has been loaded into the warehouse, it needs to be transformed. Okay, let me rephrase that. Once the data has been sent to the ETL process, it has been extracted, and now what is going to happen is we are going to clean the data. We are going to perform transformations on that data, and then we are going to load it into the warehouse. Okay.
Excuse me, sir.
Yes.
Actually, sir, I have joined late. What is the process of ETL means what, sir?
ETL is, E stands for extraction, T stands for transformation, and L stands for loading. So you are extracting data, you are transforming it, and then you are loading it into your data warehouse. Extraction is you are gathering information from various sources.
Suppose data means that is a like a raw collection of facts and figure. We are
Ex-
extracting that data.
Yeah,
After that, we are loading.
then we are transforming it, and then we are loading it.
Okay, okay.
So what's happening is we are extracting it from various sources, flat files. You have databases, other CRM operations that is going on. You are getting some information from your operational systems like payment gateways. You're getting information from your bookings reservation module. All of that data is coming into one place, and that is called data extraction. After data extraction, what we are doing is we are transforming that data so that it can be loaded into the warehouse properly. And in transformation, what we get rid of is deduplication or normalizing. uh, that is, it's not exactly normalization, but okay, deduplication or reduce getting rid of redundancies. So you are basically removing duplicate information. See, we have not yet stored it into the database. So we have what we have sorry, in the warehouse. So what we have to do is we have to firstly get rid of duplicate data that is coming in, and then we are going to do key restructuring. What is restructuring? Key restructuring is that you are getting data from various sources. So for example, maybe in one table, the gender column is named gender, but in another table it's labeled as sex. So what we are going to do is we are going to restructure those into a common name. So maybe we will call both of these as gender. Okay. So that's key restructuring. Then we are going to do cleaning. It involves you have in deleting old, incomplete, and duplicate data to maximize data accuracy. Now, what is data accuracy? Data accuracy is uh, we are getting rid of outliers, and once you get rid of outliers, you will be able to see a more clean look of your data. Okay. Like when we are doing analysis, when we are trying to find the mean, median, mode, and all that, or we are feeding it into a machine learning model, then it should be working on accurate data, not some miscellaneous outlay data that is containing some outliers, or maybe there are data which is data is missing there's a column and the data got lost during the transformation, during the extraction phase. Any number of things can happen. There's some noise in the data while it was being transformed from various sources. The bits flipped, and now there's some error in our data. So we have to get rid of all those data. So that is called cleaning phase. Okay. Then you have format revision. Format revision is maybe your measurements that you have done in some tables are in one particular format, and then you want all of that to be generalized into into another format. For example, let's take the example of this one. This thing. This is a timestamp, right? The T in the between is for that. This is a UTC timestamp, and this UTC timestamp is all right. But in some databases, you will also see something like this, which is called an epoch. Okay. Now, what we have to do is we are getting these various data sources. What we are going to do is we are going to convert them into a single format. So maybe I want to use this format, or maybe I want to use the epoch format. Then what we are going to do is we are going to convert this into an epoch as well. Okay. Then we have uh, derivations. Uh, 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 this is kind of part of the cleaning process. They have provided in the separately, but okay. For example, you need to subtract certain costs or liabilities before analyzing them. Creates not that important, but anyway. So, for example, during the cleaning process, you have some data with missing values. Suppose I am extracting information from a university website, and for university, where I'm creating some warehouse, and it's extracting data. And during that data process, I can see that a student is missing its marks in a certain subject. Okay, it's a missing value. So instead of feeding that data into the data warehouse, what I can do is I can take the mean of all the other marks he has gotten and put that inside that variable. Or I can use a global constants to fill that. Maybe I can fill it with 0 instead of unknown. Or as you have seen, I think you can see that grade cards have this mark, right? This thing. So I want to get rid of this. I want to get rid of this data, and I want to fill it with 0. So that's derivation. You're deriving something, and you're taking what? Maybe I suppose you're missing marks from this segment. So I'm going to take a mean of these two values, and then I will put it here. Or I can take the mean of all the values in here in this column, and then put that value here. Okay. Next, you have aggregation. Aggregation is you're gathering it and you're putting it into a summarized uh, into a report format. What is the report format? Suppose I have gathered information from three sources. So what is going to do is they is going to make a data dictionary of all of that that I have gathered, and then it will also note down how many rows there were in the data sets, what data was what how many data sets were removed, or they were cleaned, right, cleaned out. So how many were deleted from the data set, how many had missing values. So basically an overview of everything that has happened will be present in the aggregation phase. Then you have integration. The same thing. This is it's funny to see that the same thing. The key restructuring and integration are the same thing. They have just this is the duplication. Anyway, so integration is also the same thing. There, the diverse name needs to be changed. The diverse name and values are being changed to a standard name and definition. So maybe I want to follow a particular format. That is one thing. I want to call the uh, gender, only gender in my table. So I will set that as well. Then you are filtering. Suppose you maybe I don't want all of this data. Maybe I only need this much data. So I will get rid of all these data. So that's filtering. Splitting. Splitting is, suppose let's say I'm going to store this thing into one particular table. This is this into another particular table. So you're splitting it. Then you can join it using natural joins. See, it's basically a database, so you can perform the database functions as well. Summarization is again the same thing as aggregation. Same thing. They have said it again. Validation comes under cleaning process, so it's getting rid of the null values. That's what it's saying here. Then finally we have data loading. Once your data has been transformed fully and properly, then you can load it into the warehouse. And there are types of incremental loads. We know what incremental load is, right? Say 100 data set has been completed, send it to the server. Again 100 completed, send it to the server, like that. Then you have there are two types of loads: incremental, batch incremental, and streaming incremental loads. This is kind of like when you are dealing with real time system. In this, the updates are coming in rapidly. Suppose even this the in meeting that is going on, you will see that where is it, this thing, yeah, this is for captions, right? And when I'm talking, you can see that it's transcribing all of that in one go. And maybe Google is storing this information in somewhere. So this is a real time information, and this information is being sent to their server. My voice is being sent to their server, and then the server is changing is sorry the server is there's some LLM system, natural language processing model there, and that model is basically understanding what I'm saying, and then it's converting into a text and then sending it back to this platform. If they're sending it to this platform, they might be also sending it to their data warehouse as well, to understand how people are using their services and how this LLM is working. This all of this data can be of great help, right? So this is an example of streaming incremental. Okay, and another one is batch. You make batches of a particular uh, updates, and then you load it at certain times. So usually during off hours, off peak hours. So peak hours are like today, right now. Maybe 10 a.m. not a peak hour. 12 p.m. That's a peak hour. 3 p.m. That's a peak hour. Again, when some people have come home, they're resting, and then they're doing some booking, then that their peak hour. The peak hour will differ. It will differ based on the audience and on which type of services you're providing. For example, maybe Google is seeing that in India, or in particular IGNU, the classes, the peak hours are from 8 a.m. to 6 p.m., because during that time the Google meet.google.com is being used the most. So they can what they can do is they can update their system after that time. So maybe at 10 p.m. they are performing updates. They are updating their system. So again, challenges in incremental loading. You have data structure changes when you're doing the when you're loading it. What can happen is the formats in your data keeps on changing. So that can lead to some incompatibilities that interfere with the loading process, because when you are loading it, you're also validating it. You cannot just load the data. What is loading database? Loading data into warehouse is also a database. So we are storing records in another database, and when you are storing it, suppose now if you look at this thing is actually not, this is stored as a string, like this. So in my date, in my schema, it is mentioned that this column, the column is number at 1, 2, 3, 4, 5, 6. The sixth column has a data type of varchar, right? Variable character. And then I'm storing in this data. This is a number. Epoch is an integer. So I cannot store integer into a varchar. So this will cause some error. And if their data structure keeps on changing, for example, if someone is not using SQL, now SQL is always going to give you structured data. Some people might be using MongoDB. MongoDB is JSON based. So JSON based doesn't has a particular structure. The structure can vary, right? So that will cause some problem. And suppose your data load has been changed, you are changing into some another database, you're gathering information from another database, and that database is not structured well. So that will cause problem again when you're loading it, right? Then processing data in the wrong order. uh, for example, if you have you process the data for your cancellations, and then you process the data for your this one booking. This is below this.
MongoDB, sir,
Mhm.
MongoDB basically store PNG type of data, like maze format, PNG, JPG, that type of data.
Yes, and PNG, and these are all unstructured data. This data is very hard to process, right?
Like suppose in e-commerce website, data warehouse means exactly some process are there. So data is extracting, and at a information it is stored like in a warehouse. It's stored as a information.
No, no, no. It's not storing information. It's still storing the data. The information will be gathered by some data scientist or some data analyst from the company. For example, in your case, the e-commerce website. So e-commerce will have customers who are purchasing particular good food and all that, and then this data is going to be stored in a particular warehouse. Okay, and in that warehouse, what can happen is now someone from the marketing team will ask the analytical team to do some analysis to find some trend, that which product is doing good, which customers are paying more, something like that. And during that time, whatever information you gather, that's the information. Whatever you are gathering during the analytical process, that is information. Okay, so there's a magnitude of data present, and then from that you might be using some visualization tool, right? You are using bar charts, you are making histograms, you are making pie charts, and pie charts will give you an overview of the data. You are looking at an overview of the data, and through that you can do some more exploratory analysis. Exploratory is you are going in depth again, you are gathering data, you are applying some other algorithms to it to transform it better, to understand it better. Okay, so that's the information part. So before we can begin that, and that part will come in your next semester, that how people are doing that. So ML, what is ML, what is data science? Data scientists are also doing the same thing, ML people are also doing the same thing, because ML is also learning from this data set only. Okay.
Yes, that is my concern because data science in data science also same process is going on.
Mm-hmm.
So in data science also data whereas is there in data science data is it's in raw format and it is extracting everything from the raw data.
Yeah,
After that.
and the raw data is stored in the warehouse.
Yes. Okay.
Okay, see, why we are storing into a warehouse, right? We have all that in our hand as well. So what's the point of doing that? See, suppose this is your real time database. Okay, users are doing some your user data is stored here only. Okay, and users are able to see this data from this database. Now, why do we need to store it into some other database, other big database? Why can't we just take the information out from this one? We can do that, right? But then what about some other sources? For example, this database is not containing the product details, it's only containing the user details. user authentication details, user preferences, and all that. And maybe there's some other database that you have created that stores the other type of data. For example, food, grocery, and related information, and which user bought which grocery. Then to perform only this data, if you are performing analysis only this one, then you are missing out on this information from this. And why would you miss out on some information which is already there? Then what you can do is you can gather information from this one as well, then from other source, from another source, and then you are doing some loading, you are doing some analysis, right? So why are you gathering this? Let's just put it all into a single base. And another thing is that this will also create some load on this system, because now users are also accessing this data, and you are also accessing this data. And if it's a large company like Google or something, then there are hundreds of thousands of analytical team, data scientists, ML people who are working on this, and this will create a massive overhead on this. Because see, this particular user is only updating the rows related to it, whatever it is updating it. But what are you doing? You are reading the whole data set to make sense of it, and that is going to be costly. That's a costly operation for a database to perform. So instead, you can just store all of this into this separate, and you can analyze from this data source. This is you. So you are keeping all of this safe, and you're only extracting data from this thing. Okay. And this is the part that we'll study in the next semester. And now we are understanding how this part works, how we are transforming it into our warehouse. Okay. So again, the same thing. What is ETL? What are the processes? The raw layer is where your raw data is residing. Staging layer is where it will be. This is the transformation phase. Okay. Then you have the schema layer. The schema layer will take care of your transformations. For example, when it's transforming into a particular structure, where is it? Integration. We are getting rid of that. We are creating another schema to store our data. And then you have the aggregation layer to get the understanding, the report. OLAP is online analytical processing. OLAP databases. Uh, what are OLAP? There's OLTP for transactional processing, and one for analytical processing. For transactional processes, that is real time, and analytical processing is not real time. You can do it later on as well. Right? Here, OLTP, online transactional processing.
OLTP means online transaction.
OLTP, yeah, transaction processing. Transactional processing is you are updating your username, you are updating your email address, you are updating your booking status, those things. That's real time, right? You don't want the information to come to you later on. You have requested for a username update, and it's taking 5 hours to complete. So that's not what we want.
So, sir,
We need real
OLTP
time.
will be the real-time data
Exactly.
where, yeah. So it will be not connected with the data warehouse, is it?
Yeah, yeah, it will be connected. I showed you, na. The
Yeah.
OLTP databases will also send data to your data warehouse, but in
Okay.
batches.
Okay.
Will follow some incremental loading strategy. It's the same thing. You can just go over this. This is what are the tools and what are the benefits. Not necessarily important that much. Uh, how we can just go over these. Okay, now this is just explaining how you can update make the process better. You can use Hadoop, and Hadoop will be you will be studying in. The next, this is for big data. This is big data. Data warehouse, big data. Big data is large amount of data. Is in the name. Big data. Large amount of data being stored somewhere. So what is that? Data warehouse. That's it. Hadoop is also Hadoop is a technology, just like SQL. Hadoop is also a technology that will deal with this large amount of data. Yeah, now we have ELT. What is ELT? Extract, load, and then transform. What does this mean? You are extracting the information, you are loading it directly into the warehouse, and then you are transforming it later on. That is, you are cleaning it later on. बाद में करोगे भाई वो, later process. So extract the information. The previous one was EETL, transform it and then load it into the warehouse. But ELT is extract it, load it into the warehouse, and then perform transformations on it. In that way, no data is lost. But again, this will be kind of expensive because you're loading it directly into the warehouse and then you are performing in operations on it. And we know that data warehouse is very slow. Okay, because it's a cold storage. Cold storage is like Cloudflare R2 you are using some CDN like R2, and that storage will be not much what you can see fast. Okay, SQL is fast. It's retrieving data from your hard disk, but your the warehouse is usually not that fast because it's containing millions of entries of data. So it has to comb through all of those to find out a particular set, and then it will send it back to you. So this is basically extract, then load it, and then transform it later on. So this, you are putting it into the warehouse, and then you are transforming it, and then you doing some analytical processing on it. The data scientists are working on it. ML people are working on it. That that thing. Marketing people are getting information from this. You can just go with this. uh, OL OLAP. Introduction to your OLAP. What are hypercube and these? This is important. MOLAP, ROLAP, OLAP, OLAP. Uh, Multi-dimensional logic, slicing, and all that. Go. Let's go into it. OLAP is online analytical processing. What are the characteristics? It's fast. Why is it fast? OLAP acts as a bridge between data warehouse and the front end. What is the front end here? Whatever the company that has built the software is looking at it. Okay, let me just show you with a quick example. That will be much better. Array. Okay. That's on tenants, and let's set the time interval to daily. Or see what I did here. This is my front end, and this is getting some data from. I have set it like from January 1st, 2025 to today, and then I hit on enter, and then it gathered this information. Now this is a your. I work at a cyber security company, and this is their dashboard. And inside the dashboard, you can see that these are the cases that it registered. Someone's tried to. There was a reconnaissance attack. Some people were doing persistent foothold techniques, and all this has been captured here. And what I can do is I can do some analysis on it now. It's presented in a visual format as well, and then I can gather this information from various sources as well. Now this data, this is from, this is old data, right? And this is called cold storage. So I'm still able to get this data from the cold storage rather quickly, right? Even if I put it at, say, January 1st, then also it's able to get the data rather quickly. So this is an example of your OLAP. So it will act as a bridge between your warehouse and the front end. And what is that front end? This company, my company's. This is my dashboard, and from the, in the dashboard, I can see that these are the cases that are going on, and then I can make some action on it. So that's my front end. So it will act as a quick gap, quick bridge between us. You can perform analysis on it now. As you can see, I have gathered the data. I can go to investigate, go to threat hunting, and I can look at my, see it's loading it. Yeah. So these are the data. I can look at the, this is their analysis. This is the pie chart. They have made some bar chart as well. I can make my own charts in here as well. Okay. Shared. Now I'm not only using it. This data is not being used by only me. My team members are also using it. Okay. Multidimensional. Okay. So OLAP has multidimensional view of the users, and that is, uh, there's one thing is called a two-dimensional analysis. Two-dimensional analysis, you have only two features. You have one feature, and then you have another one as your target. Okay. But in multi-dimension, you have multiple features, but your target is one. Okay. And that you will understand, I think, more better in your next semester. But let me give you an example. Suppose, uh, 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 mm, I think KNN is also in your data warehousing concept. Anyway, so it's containing the data from iris dataset. Okay, we are taking the dataset from iris flowers, and we are going to, the target is our, the species that we want to estimate. Okay, so let's see, it's connecting. Oh, maybe it's already there. Yeah. So this is our classification. As we can see that it's 100% accurate, and then we gave it a class to this. These are the features that we gave it. So this is some facts and figures that we provided it, and it was able to determine that it's a versicolor, whether it's a setosa or not. And it determined that this belongs to the species versicolor. Okay, so this is your data analysis. The data scientists, ML people are all doing the same thing. So here we have, see, we are splitting it into train and test data set. Then we are using the k nearest neighbor algorithm to classify it, and then we are finding this classifications. Sorry, can't. Okay. So multi-dimension is if you have multiple features. So you have multiple features, and then you are aligning it with the target. Data and information, and same thing. Let's say the cube representation. This will be a little hard to explain using just mouse. Mm-hmm. Okay. I will provide some links to some resources from where you can study this better. Okay. Because it's hard for me to explain this using a mouse. So I will provide you some resources. Check that out. If you're still having some doubt, you can ask in the next class. Okay. But this concept of, yeah, the operations, these operations are important. What is slice and dice? Was it drill down technique? Was it roll up technique? Okay, I will provide you some information that can help. I will provide you a basic, what you say, resources, and you can just study that. Um, Maybe I can explain. Let's see. See, in dimensions, it's stored like this. So if you look at this particular role, if you look at this one, only this face, you can see that it's a two-dimensional, right? So you have your Q1, which is quarters. Okay, na? There are 4 quarters in a year. So quarter one, quarter two, quarter three, quarter four, and then these are the columns that are storing some other information. So it's storing whether it was in stock or not, what was the amount, the order, the sale quantity, and all that. And then uh, above this one, look at this. This row, this particular row is consisting of mobile. This is for laptop. This is for furniture, or maybe it's looking at this particular dimension. This is a little bit hard to. You need to visualize this one. Okay. Anyway, this is the time. This is the category. So this is the sales, the mobile sales, laptop, furniture, kitchen, and in roll up, what happens is you see that all of these are same. Look at this bottom layer. This is still the same. You have in stock, amount, in order, and all that. You have Q1, Q2, and all that. But your this thing, your category has been rolled up, or it has been reduced. So this is also called dimensionality reduction. Okay, concept of data science. And here what we have done is we have basically gotten rid of this particular data, and we are looking at only this one, home appliance electronics, where because we are only if you look at this, what is this? You have mobile and laptop. These are home appliances, maybe furniture. Okay, this is going to be a little bit harder. Anyway, here you can see in roll-up process. So it can be summarized into one thing. In roll-up process, at least one or more dimension get reduced, like category here. So category was reduced to this thing. Does that make sense? Okay. Anyway, in drill down concept, it's the reverse. So you are expanding it. So here, look at this. You have Q1, Q2, Q3, Q4, and then you have January, February, March, April. So what was referred to as Q1, quarter one, quarter two, quarter three, quarter four. Now you can see that it has expanded. So drill down is basically you can think of it as like a slinky. So a slinky is first of all pressed. It was like this, and then you stretched it, so it becomes like this. So basically, this data has been updated. So this was containing less amount of information, and now it's containing more information. We can directly look at in the sales of January, sales of February, sales of May individually. And this is useful because this will uh, by splitting into like this, we can figure out the seasonal trend, because now we'll be able to see we will be able to look at October, and we can see that there are some stock that is going up and down because this is the festive season. Okay,
That
Durga Puja.
we can say that drill down is just reverse of roll up.
Exactly. Also called
So
roll down.
yeah, so if we are putting just like this arrow is on left side, so this is roll up in
Yes,
the
yes,
same
yes, yes.
example.
If you take this one and you if I reverse this, then this is roll up.
Yeah, okay, okay,
Okay.
thank you.
In
यार
slide.
वो
Yeah,
एक्स्ट्रा
yeah.
इंफॉर्मेशन किधर से आता है?
Sorry.
Where does that extra information come from? Like
Quarter one,
from
quarter two to
yeah,
January, February.
yeah.
Yeah, it can be realized by some. Maybe there are already some metric in place. See, quarter one, quarter two is already an information, and from that we can extract that it was January and February. And when we are extracting it, when we are dividing it, see, quarter one consists of three months. Quarter two will also consist of 3 months. So what we can do is we can divide that data into three equal portions. Or maybe it is possible that the user usually had January, February, March, and all that, but later on it was characterized as quarter one, quarter two, based on the timestamp. So the timestamp will contain the month, right? If I look at this example, you can see that the month is 5, so it falls under quarter two. So based on that, what the user may have divided into Q1, Q2, Q3, Q4. And later on, if you want to look at the month, you are going to divide it into only the month. You are going to divide it into month wise. So 01 January, 02 February, 03 March, and so on. So this data is already there, and then you are performing some, you are shrinking it down or you are expanding it based on your needs. Okay. Then you have slice where you have a dimension and you just take a slice of it. And once you have taken a slice, then you what you have. If it's a cube, if it's a three-dimensional space, and if you take a slice, it will be converted into a paper, right? So it will be a basically two-dimensional thing now. So you can see that they have taken the slice of the top. If I take a slice of the top, then I will have all these features as well as what were these features? This thing, in stock, amount, in order, sale quantity. So we have a two-dimensional figure as well now. Okay. Mm-mm-mm. In dice, you just convert it into a smaller portion. So I have taken this portion now, right? Q1, Q2, mobile laptop. Q1, Q2, mobile laptop. So it's basically divided into smaller portions. In pivot, what is pivoting? Like you are just changing the faces. You're just turning it up, turning it. Look at this. Your time was initially at the top, now it's at the bottom. Category was in the bottom, now it's at the top. Pivoting means moving it, right? In the first semester, you might have heard about quicksort algorithm. In quicksort algorithm, we also take a pivot element, and that element is basically moving from place to place. So pivot is something that helps us in moving. And in the Friends classic, if you have watched Friends, so Friends they also say move, pivot, pivot. Ross says. Anyway, OLAP functions. What is its function? You can just go over this yourself. Da, da, da.
So lab only
Mhm.
works on the cube, or is there something else?
No, it will work on various things. Like no, no, no. See, the you have cube, you have the data in data warehouse. The data is stored in the form of like this in dimensions, and then OLAP will do some pivoting, or maybe it will slice the data, or it will do a roll up or roll down based on the user need, just like how I did here. See, previously, if I okay, let me set it as relative. When I set it as relative, it shows me as last 25, 12 hours, last 15 minutes, last 30 minutes. This is categorization, right? So if I change it to daily, now this is another layer of this is another. What is this? When once I set it as daily, is it a roll down or a roll up? What do you think?
Roll down, sir.
How is it a roll down? I'm looking at daily intervals now.
So from months we are coming to daily.
No, no, no. In relative, I had last 24 hours, last 15, last 5, last 12, last 24, and then I
Okay.
changed it to daily. So now it's
Roll up.
showing me the data for today, full day.
Yeah.
But if I change it to relative now what is this? Is this roll up or roll down? I have more information now.
More information roll down, no, sir?
Exactly. And if I change it to a daily, this is a roll up.
Yeah, correct. Correct.
Okay. And what could you? I can give you an example of dice. Dice is you are only interested in certain elements. So, for example, let's say I am again changing it to absolute, and because we don't have much data right now here, and let's take this one, and then what I do is I want to get rid of this IP. So I'm going to click on this minus sign, and you can see the data has shrunken. So this is pivoting. Sorry, this is basically slicing. So I'm getting rid of the data that I don't want. I'm only looking at the data that I want to analyze. So I got rid of certain features. Okay.
Yeah. Right.
Just like here as well, you can see in the table I have certain data, and if I want to get rid of this description table, I will just uncheck it from this table. I will do this, and it's gone. अरे गायब ही हो गया पूरा. Okay. So hypercube and the multicube. So in multicube we have each dimension can belong to many cubes. Each dimension belongs to one cube only. Okay, I will give you an resource for this to understand what are these hypercube cube. How what is the dimension? What is this cube figure? How to create this figure? Okay, what is multidimensional analysis? What is this thing? I've just explained you what are happening here, but I have not explained what is how to make this right. So I will provide you with a resource. You can just check it out, and I will discuss it later on again. And I think you have classes at Merit, right? Offline classes.
But merit actually, sir, OL and ODL students both are there.
Uh-huh. So this is OL students only here, or ODL as well?
ODL also. We are here.
ODL as well, right? Okay. Okay, so for OL students, you only have online classes, right? And for ODL, you have. Oh, your classes have started. Or
Only practical classes.
okay, only
That is
practical
offline.
classes.
Yes.
Got it, got it. Okay, okay, okay. Okay, for the OL students, I will provide you with some resources. I will provide you with all of you with the resources, and you can just go over them. Okay. Then let's see if in the next class, if I am able, if Kavita ma'am is taking it, then maybe she will be able to make you understand it better. Because I don't have my pad right now with me, so that I can draw on my paint. Okay, so it's kind of broken down a bit. Otherwise, anyway. So these are the steps to creating an OLAP. You extract information from Excel sheet again. The same thing, ETL processes. See, the OLAP key just sits between the warehouse and your client. And this is your employees. These are your employees. And why is it sitting in this queue? It's because this will be faster to analyze. So these are its advantages. Just go over these. Next, we have OLAP servers and their types. OLAP is relational OLAP. So in this, you will have SQL that will be storing your dimensions and all that. Uh, MOLAP will consist of multidimensional. So it will consist of your it will contain the dimensions. It will store the dimensions. Like what we did in the previous one. Uh, uh, OLAP will be the hybrid of R and relational and multidimensional. I will give you an resources for all these. Okay, just go over that. Dolab, I don't think you have Dolab. They don't ask this one. Desktop. Basically, as a what do you say? It's going to store the information on your system, and you can access it from there as well, from that thing. This one is not important. Only OLAP, MOLAP, and ROLAP are the important concepts that you should know. And finally, you have trends in data warehouse. So, okay. एक सेकेंड. क्लास कितने तक है तुम्हारी?
9 to 11.
Oh, we have time. Okay, okay. See, the unit 6 is just going to cover uh, various concepts that are used in data warehouse. So I had mentioned previously that data lake. What is the data lake, right? That the data is stored in the form of data lake, and then in the warehouse it is stored in the data lake, and then information is gathered from there, and then analytical processes use it. But what is the data lake? What is the data swamp? So this is what we are going to study in this unit. So what are the challenges? Key challenges. Computational technique, how you are computing the data. Maybe share some design problem in the schema. Quality, what the data that you are storing. Maybe there's some erroneous data. The size, there you have large set of data and now you are running out of space. Operability, because the size is so large and there's some it's containing low grade quality is affecting your operational, that is your API services, your other services are going down because of it, because of the highest demand of this storage. In memory representation, so you cannot store this information in the when you are storing in OLAP. Is why is OLAP so fast? Because it's storing information in the RAM, and in RAM there's not much space, so the space will be utilized quickly and the system can crash anytime. User centering interface. So, for example, this interface is built for us. So, it's based on the user who's going to be using it, the clients. Pioneering infrastructure foundation. You have this is basically covering the cloud providers who can provide you with the data warehouse. So, you have AWS, you have Google Cloud, you have Cloudflare. NVIDIA also is giving you cloud platforms for computing it, right? Okay, why do we need the cloud computing concept is also you will understand in the next semester. You have cloud computing and like basically how you can set up these things. And why do we need cloud? Because when we are doing analysis, we will be heavily using some. For example, I opened this Google Colab, right? Google Colab to perform the KNN classifier. Why did I do that? I could have opened it on my own machine, okay, but again my machine is old and it won't be able to handle this type of algorithms, so I'm not going to be parallelizing my machine anyway. So that's why we use cloud platforms. So we'll be storing our data in the cloud, and then in that only we will perform some analysis. Even in this example, this data is not stored in my computer. This is stored in in their computer. This is Alpha XDR. So by Stellar Cyber, sorry. So Stellar Cyber is taking care of all that. And I have to I have to explain another thing is that what is this cases, how they are making it. So you have multiple logs that are happening inside your computer. Even as we are speaking, as I'm using this internet, this bandwidth, logs are being created in my system, and these logs will are being stored at your Defender. Your Defender is storing all of this information, and then what it can do is it will send this information to my this service, okay, to this data warehouse. And inside this data warehouse, there's an ML, machine learning model, which is analyzing those cases and trying to create cases, analyzing those logs and trying to create cases. For example, if I go back to the home page again, I can see there are it has labeled something. See, when I hover over it, there's something known as 1 out of 397. So 1 is critical and there are total of 397. So only 1 is a critical hit. So it was able to label that data. It was able to predict that thing, right? So there's some ML model going on that is able to understand this huge amount of data. And it's saying that out of all that information, all that logs that you have sent me, only one of them seems critical. And if I click on that, let's see what is it, what it is. Critical. See, all of these are zero. Critical here. This one is critical. Microsoft Defender say reconnaissance attack. Let's view this one. High fidelity. From this desktop, something happened. Their IP address, the name. So the user domain was Azure AD. Azure is for Microsoft. AD is Active Directory. So the user was using the Azure Active Directory, and this case was repeated that time. This is summarization. See, there are data here. If I come to JSON, you can see this is the data, all of this data, and it was able to summarize it into as well this thing. This is the details again. This is the timestamp. These are some values. These values are filled by my, and look at this one. You can see the threat intel is NA, not available. So this is my missing data. This data was missing and it was replaced by some global constant, which is NA, not available, or it can be set as 0. You can set it as 0 as well, or you can take a mean of these two data. So 75 divided by 2, that is again 75. So instead of doing that, because threat intel is important, I cannot just take a mean of it. So if it's not there, it's just showing me that not available. So that's good. Okay. And it was also able to make a prediction of the fidelity and the severity of this thing. Complexity, obviously I was not able to explain you how the multidimensional cubes are being set up because I have only mouse. I cannot use that to explain you how it's working. So again, OLAP cubes are exceptionally large data set, and this will be very hard to explain or to understand how they are working. Okay, we can get an idea of how it's working, and then you can go on from that. But again, this is very complex. Optimizing and innovation in query language. What is query language? Query language is basically just as for SQL, it's structured query language. So query language is basically how you are querying data from a data source or your data warehouse. So we need some innovation in that regard as well. Then you have data visualization, how data is being visualized to the user. There's something called, they have also include something called GraphQL. Why is it mentioned here? This requires specialized tools, for example, GraphQL. Okay. Data of the system. There are other critical issues with AI ML based data visualization. that it needs for data visualization is in how you are going to chart that data, because you human beings we are not going to get some data by just looking at numbers. If I just show you with a bunch of table, if I show you a table containing 100 records and tell you to go over it and give me an estimation of what you think is happening here, then it will be a tedious task. What instead I can do, I can just take the whole data and I put it into a bar chart, or I can make it into a pie chart, because the charts will give me a more better visualization, right? Looking at the bar chart, I can see, okay, this class is the bar is very high for this one, so something is happening here. Maybe some outliers are there as well. I can see that some people have chosen, there are 2 3 people containing a very small bar, so maybe they are my outliers, so I will get rid of those that information. Okay, so visualization helps the data scientist a lot, and that's why we have so many tools in our Excel as well. Excel is also an example of how data visualization, this data science is being done. Okay, if you go to a word, where is the data tab? Oh, yeah, in the data, you see data analysis. If I go over this, I can see I have ANOVA, I have correlation analysis, I can find out covariance, F test. I can do for yeah, Fourier analysis as well there. Histogram, try to find moving average, T test, pair tests, all of these, one tailed, two tailed, all of these tests I can do from Excel as well. Okay, and for visualization, look at this. What we have visualization. Uh, yeah, we have charts, right? Various charts, pie chart, bar chart, histograms. Uh, what are my recommended chart? Okay, pie charts, dotted scatter charts, scatter plots. So these charts help us visualize the data much better. Instead of just looking at some numbers and looking at some facts and figures, what I can do, I just take the whole thing, convert it into a chart, and then look at the chart only. That will give me much more clarification over the data. Now, what is data lake? Inside your database, the data lake is the portion that is containing the largest section of the data. So your data warehouse can be visualized in the form of a data lake. This is a lake, and in the lake you have the water is your information, and inside the data lake we have swarms. This is a swamp, this is another swamp, this is another swamp. And what are this swamp? Maybe this is for AI. The AI is training on this data. The sales team, this is for sales team. The sales team is training on this particular data. This is for my marketing team. Marketing team is studying on that data. By creating swarms, what we have done is, now the query won't have to go through all of this data as well. All of this, it can only process the information present in this particular swarm. Okay, so that's what data lake and data swamp is.
So it's a part of data warehouse, right, sir?
Exactly. Yeah, exactly. So
Okay. Or we can also maintain this kind of data lake within our operational data, like
mhm,
operation data, sales and marketing data separately, and within
yeah,
that there's a data lake. Is it my
yeah,
understanding correct, sir?
yeah, exactly. Now the another important feature of data lake is that in data warehouse, I told you that we have to transform it in such a way that it can be stored in a table. Data warehouse is just basically a database. So in data warehouse, only structured data was can be stored, right? Only structured data that is coming from databases, operational units, flat files. Even flat file is not considered. structured data. It's still a semi-structured data. But anyway, that type of data is being sent to the warehouse. The ETL is going to transform it into a tabular format, and then it will store it into warehouse in my load it into the warehouse. But in data lake, I don't have to worry about any of that. What I can do is I can put raw data in that. I can put data from anywhere, even from websites. What is websites? HTML pages. You can store HTML pages. You can store information coming from your mobile apps. So mobile apps are also sending data constantly, so you can store that information. IoT devices, internet of service devices, right? If you have a device that is, for example, Alexa, that is an IoT device, right? Or if you have a light that is enabled by your voice. So if you say light on, then the light switches on, and then you say light off, the light switches off. So that is also an IoT device. Social media channels. So you are storing data from various sources, and all of that data is being stored in this lake. Okay, there's no restriction. This is basically a cold storage. In this cold storage, you are storing whatever you want. Okay, and afterward, what you are doing is you are making swarms, and these swarms will help you categorize those data into a particular format. So your AI is working on some maybe, or maybe say your sales team is only represented is interested in the uh, transactional processes. So you will store all of the transactional processes in this particular swarm, and then the sales team will feed it, uh, get its information from there. So that's a huge difference between data warehouse and data lake, and mainly data lake is being used in overall everywhere. Data warehouse was the concept, it was bought in, and then it has been replaced with data lake. Now even this information that you're seeing, uh, that I showed you, this one, this is also I told you that this is also coming into a data lake. All of these alerts, different types of alerts that you see. So for example, my alerts are coming from sorry, my logs are coming from my Windows system. My logs are coming from my for example, maybe Linux systems. It's coming from my networking devices, it's coming from my mobile apps, and all of that information, all of that security information is being stored at that data lake. And from there, some ML is understanding that data and categorizing it. It's clustering it. That's clustering is unsupervised learning, and classification is supervised learning. You will understand, we will discuss that more later on. Basically, in supervised learning, you provide some data, and you say that this data should output this particular output, and then the model will train itself. It will create a function that will be able to predict future values. For example, here we use some trained data sets, and it was able to, then we here we fit the model. So it was training on the training data set, and then later on we made a prediction on the test data set, and we can see that it was 100% accurate. Now this is 100% accuracy is very looks good, but it is bad. Why is it bad? Because it's overfitting. This is called overfitting problem, and we will study that again. You will study it in your next semester properly. But overfitting is also bad. So we are obviously looking for something between a 90%, 80%, 85% to 95% is good. Above that, it's just overfitting it. So maybe what I can do is I can reduce the uh, training set to 50%, and then I can perform all this again. So I will have a different accuracy maybe. Okay. So I have that's data lake, the schema on right. So schema is created when you are writing to the data warehouse. The schema, when you are loading it, you are following some schema, right? But in data lake, schema is created when you are reading it. What does that mean? In here, when I opened this one and I clicked on this information tab, you can see that I'm getting the information in the form of this JSON, right? It's sending me this information. All of this information is stored in it somewhere. Okay, in the data lake, the information is stored in a different format. And when I click on the get, when I'm trying to read it, when I'm trying to get the data from the data lake, it's converting it into a structure. It's providing it a structure, and then it's sending it to me. Whereas in this one, The schema was defined when it was being written, and in data lake it's being defined when you are reading from it. What are the intended users? For business analytics, you can use data warehouse, but for other purposes like scientists, developers, or for ML, you can use data lake. Okay, you can say that even business analysts can use it. So what's the problem? You can just switch to data lake only. And data warehouse will be best for those who are working in a the organization is a smaller organization. They are not relying on unstructured data. They are only relied on structured data. Then they can go for data warehouse. Otherwise, if you are relying on some other sources, you are seeing that your data is going to contain unstructured data, semi-structured data, like information you are scraping from a website. So when you are scraping information, that's again unstructured data. When you are scraping something from social media, so in social media you have interactions, and in those interactions you're scraping the comments of that Instagram post or some Facebook post, and based on that information you are trying to predict something, you are trying to understand the mindset of people. Then that type of data should be put in a data lake. Okay, the price data lake is again, you because this is basically a database, so you will the query will run fast, but it will cost higher storage. But in data lake, the queries are getting faster with low costing storage. See, this one I was able to search without much delay, right? And I'm even searching for old data, right? So this is from way old, like 3 4 months ago, and it was still able to send me that data in a few seconds. So data lake performance is improving, and it also doesn't take much storage. Okay, doesn't take much storage. And what does this low cost storage means? Low cost storage is basically in this one you will need to use some SSD, because SSDs will provide you with higher query time, higher access time. But here you can also use HDDs as well. No problem with that. Okay. So even if you have low cost storages, you can still get a relatively faster output query. Data quality. Now, obviously, in data warehouse, you have only created the schema yourself, so that the data will be highly curated for the whatever purpose you are using it. But in data lake, any data may or may not be curated. So raw data is stored in data lake. So obviously, the data quality might not be that much high. Okay. In this one you can find the metadata as well, right? Because this is basically a database table. You are creating tables inside it, so it will have a data structure, it will have a data dictionary, so it's easier to understand. But in data lake, any type of data can be inside it, so data quality is not that high. Okay. Type of analytics: business intelligence, which is BI, and Power BI uses this Microsoft tool Power BI. Visualization and batch reporting can be done for this one. And mainly data lake is used for machine learning, predictive analytics, profiling, and data discovery. So this is KDD, knowledge discovery from data. Okay, so these are the processes that are suited for data lake. If you're training ML, if you want to predict something, if you want to profile something. For example, this is an example of a profiling. It was able to profile it into some cases, so that's profiling. Okay. Data discovery is you are discovering some information from the data that is present. So for example, if you see a trend, if you're seeing that someone is buying bread and then butter. Okay, so you'll see that, okay, whenever someone buys bread, butter is always in that list. Okay, or not always, maybe most of the time, 80% of the time butter is in on that list. So what kind of data discovery did you did? You're finding out that, okay, people are more likely to buy butter if they buy bread, or they are more likely to buy bread if they have bought butter. So what they did is, the supermarkets, what they can do is, where they will put butter and bread on the same aisle. And now when someone is picking up the bread, they will say, oh, butter is also here, so they will pick that one as well, even though if they have already butter at home. But still, human mind is feeble like that, so they will just take the butter as well from there. So that data discovery. Agility, well, the confusion is fixed, the schema is fixed, so you cannot, what do you say, you cannot just transform that schema again. But in data lake, it's highly agile because there's no schema, right? So this thing, there's no schema, so it can store any type of information. Security, as it's basically a database, so you can use some locking principles. You can create users on that, and with that you can have a secure storage. You can improve the security of your database. But in data lake, it's not a database, so obviously there are some issues with security. So this needs to be accessed properly, because your data lake basically a machine which has some storage. Okay, so the machine can be hacked easily, so your machine needs to be protected. Okay, the access to that machine needs to be protected. Here you can see that you have, this is your data lake, then it will be divided into some ponds. Pond will contain some the same data, it will contain in other volumes. And then what happen is, here this is the archival data point. What is archival data point? All of this is containing data that is in the kind of real time. And this archival will contain data maybe 2 3 years old. Any data that is less than 2 years old will be sent this there. More than 2 years old, it will be sent this in this pond, because analysis might depend on only this one, right? So it will structure it like that. So the most recent data set is easily accessible, and if you want to access the archival data, then you can also do that. You can just set it like this. So here you have data ocean, which is the biggest portion. Then you have a data lake inside it. Then you have a pond, and inside there you have data puddles or swamps. Okay. Mhm. In the various type of data sources, you have the ingestion layer. It's extracting the metadata and processes. Then it will send it to the storage data set, storage layer. Then this storage, this information will be transformed. So cleaning, data extraction, binning, all of this will be performed in the transformation layer. And then you have the interaction layer, from where you can query it. So that's what I explained here. Data swamp, same thing. Okay. Okay, just go over these ones. This is just the theoretical portion. There's not much explaining in this one. You can just go over it easily. Real-time data processing is just basically OLTP and OLAP combined. Hadoop is a Java-oriented framework comprising of storage and processing, and it was developed in the HDFS file system. Uh, it uses some functions like MapReduce, Hadoop Common for data warehousing. It's not important right now. You can just go over the theoretical portion. So basically, it's a data warehousing framework. How you can use it. Mhm. I will give you the extra resources for this one as well. And maturity, that's it. Okay. Okay, I will provide you with some mm, notes, and are all of you in the MCA OL group? WhatsApp group is MCA online support group.
Sir, we have a group actually, merit group, WhatsApp group.
Oh, you have a merit group, right? Is the official merit group?
No, not official. Actually, one student that Mohit, he
Uh-huh.
has created that group. So if have any notes, then you can share in that group.
Okay, can you provide me with the joining link?
Link
Is
I,
there a
I
MCA
am not
online support
admin.
group as well, sir?
If Mohit is here, then he will give you.
Okay.
Is there a support group for MCA online as well, sir?
In the MCA online support group, Mohit, Mohit, uh, is he an admin
Mohit is admin.
of MCA support group?
Not MCA support, merit. The group name is merit, MCA new.
Sir, you
Um,
have an MCA support
Maybe
group as
another
well?
group is there. I have no idea. Actually, we are added in merit group.
okay. Wait a minute. All another thing that we can do is to social media. This is okay, BCOL. Okay. Okay, I will add another one group here. MCAOL. Okay, join that one. Just come to Merit, then social media links, WhatsApp group, and inside there I will have another one, MCAOL. Okay. Uh, okay, MCAOL is okay.
We'll be able to join on our own, sir.
Huh?
We will be able to join on our own using that link.
Yeah, yeah.
Okay, you'll be creating it now, sir.
Yeah, I'm creating it. Just give me a second.
MC underscore new is there. MCOL is not there.
Sorry.
MC underscore new is there.
Yeah, I will add
Okay.
MCA new is already there, right?
MCOL is not there.
Yeah, MCOL is not there. I'm adding it.